volume of
sodium thiosulfate.
No, I don't second but let me manage my own. Now, they say in this place concentration over 10. The change in concentration. These are the different concentrations we have here. In this place, there is a different concentration. That's what my aunt was trying to. I said we are going to this. Now in this place, we are going to plot a graph of this. At the end this time. But you don't know this. I wanted to leave this one for you to go and do.
Let's do it.
Yeah, now we have.
Let's do it together.
Let's
do it together. We are one family.
So that we can move to the next one.
Let's do it there.
Okay. Let's do one or two or even three. It's just small values now. It's not much. Which I know I have increases it to 15. I have a lot of values to plot. But these are just small values. Hello. Okay, let's go. When you say different concentration, when you say different concentration, remember this was the initial concentration. Sorry, this was the initial concentration of sulfate. Okay.
Yes, sir.
This was the initial concentration of thiosulfate. So you now write C1 is what? 0.2. Okay. What was the total amount we picked? This added together will give us what? 20 plus 0.
20.
This will give us our final volume. How many volumes of water do we pick?
0.
So our B1 is 0. Okay? So we are looking for what?
C2.
Now remember C1 equals to V1 equals to C2 V2. Now we are looking for this, right?
Yes.
So we now say C2 equals to
C1.
how much?
Yes. Yes.
Now, the C1 was what?
0.2.
0.2.
Okay, B1 was what?
0.
Divide by 20.
20.
Now multiply this times this will give us 0.
Yes.
Right?
Yes.
So the answer still remains this. The initial answer still remains this.
0.
This concentration, because there's nothing like water added to it.
Excuse me.
It's 0.
No, 0. It's 0.
I know. The initial answer will still remain this because, wait,
There's a mistake somewhere.
Are you sure?
the initial answer will still remain this. Okay.
V1, is it 0?
Okay. The problem comes from here. We are using this, not this. Sorry. We are using the HCl, not this. How long are you wanting?
2.0.
The initial is still 0 because 0 divided by 20 is 0.
It's still 0.
So, but the initial answer, because, hear me on, because water was not added to this solution, we pick only 20 mils of this.
Yes.
So the concentration of this 20 mils still remains 0.2. I'm confused.
I'm confused.
For instance, now we have a stock solution. Inside this stock solution contains 0.20. Get my friend? Now, when we pick 20 mil of it, the concentration, we are picking 20 mil.
I'm listening.
You are picking 20 mils of it, preparing it in 20 mil. So we are picking 20 mil. This is the concentration, C1. We pick 20 mil of this solution. Okay? This is 20 mil now.
Yes.
Yes.
We pick 20 mil of it. That's C1 and B1, sorry.
B1.
We are preparing it in 20. That's the volume, total volume of these two. Is still B2.
20.
So we said here should have been, sorry, maybe
20.
This should have been
0.2
2 times 20.
times 20. Initial volume we picked from this container. Okay, Dorcas, the first thing Dorcas did, she picked 20 mils from here.
Yes.
Okay, that was the initial volume. The concentration of this is this 0.2. This is the concentration of this solution. Now Dorcas picked 20 mil, and we are mixing all the solution to be what? 20. Guess my point? So the final volume is still 20. So you now say 2 times this. 0.2 times this.
It's correct now, 0.2.
Divide by 20 will give us 0.2.
0.2.
So the initial what? 0.2. Manandi.
Yoko now.
But who don't understand the point so that we can know this. Okay, let's come again. This is our solution that Dorcas prepared. This solution, the concentration of this solution is 0.2. That's the C1, initial stock. Now Dorcas choose to pick 20 mil. This is Dorcas now. Now she picked 20 mils of it into this flask. We're looking for total volume of 20. So there was no water added. So the volume there is what? 20. So the initial volume of Dorcas pick was 20 and the final volume was 20. Oh, okay. I'll come again. When we pick this first one, there is no water. Right? What was there is just 20. So the final volume and this one will be the same. Now once you do this, it will give you 0.2. Meaning that the concentration of the initial and is this, and it will give us the least value. That's the concentration will be 0.2.
That means that V1 is 20 now, not 0.
Yes. We don't use the water, you use this.
Yes.
Okay? Now, when this is the final volume you are preparing. Okay? Now, what Dorcas speak again? In the second one was 15. Now you move the 20 and put 15. Now calculate. What will you have? Calculate now.
Okay.
0.2 times 15 divided by 20. You know, calculate on me. Okay, that's right. Okay, mirror.
0.15.
0.15. How?
Yes.
So you put your number 2, 0.15. When 5 mils of water is introduced to this, that means it reduces the concentration because it's diluted by 5 mil. The concentration will be 0.15 instead of 2 molar. 0.2. So the same thing comes to this 10. Yes, this is constant because this is the final volume we are picking. This plus this is what?
20.
That's the final volume. Now, you change this.
Okay.
Yes, my friend. You are changing this only. So once you put 10 here, that's your V1.
1.
You change here to what? 10. So this time this divided by this will give us what?
0.1.
Come on. 0.1. Do you understand now that when you dilute it, the concentration also decreases? Once added water to each of these concentration, it dilutes the concentration of the acid to give us different
0.1.
concentrations. So this one, you will do what?
0.005.
So you use these values to say your graph. For instance, you have a graph and I say 0.05, 0.1, 0.15, 0.2, 0.25. This is how your scale will look like in the concentration, different concentration. And your time, what's the highest time here? 4.
4.
The lowest is 2. So you can pick which number you can pick. Let's say 2, 4, 6, but you must get to this number. The highest number must get to. Let's use 5. Let's use
1.
from here. There is a graph, a number, a graph. There is always a number. It's small lines. For instance, now we are having a graph like this. This is 2 cm. This from here to here is 1 cm. From here to here is 2. So 2 cm here represents 1 second in my own graph. From here to here is 1 cm cube in the graph. Now from here, you don't take my own time of graph. I mean, you're going to your graph now. You're going to your graph now. Boss, something too. So if you pick a graph book, this is example of how graphs look like. Now, from here is 18 line that normally say 1, 2, 3, 4, and this thing one will be 5. Okay?
Yes.
Now the same one will say 1, 2, 3, 4, and 5. So this first box is called 1 cm cube. The second one is 2 cm cube. So if you can see, I didn't start my numbering here. So I will say 2 cm cube represent 1 second in the time. And also in this place, I will now shift this one also to say 0.05. Shift again.
0.
This is 1 line, 2 line. I skip this one, write this one, 0.1. Skip this 1 line, write 0.15. Skip this one.
0.2.
0.20. Skip this one. Write another line here. 0.25. The highest number is 2 in the concentration. The highest number here is 2 in the concentration. Now there is a thin line here. Here is 1. If you want to count so that you can have these 0 points, you count this thin line. Okay?
Yes.
So let's say this is 1, 2, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.
See, if you want to title it, how will you title it?
I will title it a graph of concentration against time. A graph of concentration against time.
At what scale?
At a scale of 2, at scale of 0.5
Representing
2 cm at the concentration axis. While 1 second represents 2 cm at the time axis. Okay. Now when we get to this point of a graph, now we note this. You now say the first one is 0.2. Let's say this is 1, right? And this is 2. Now 2, this time, at what concentration do we have it? 2. So this is 2. We now trace it. You don't dot to, you just take it here. So this is 0.2 and we have 0.2. 2 here, 2 here. And this is 4. You take around this 1, 2, 3, 4. So 4 at 4 we have 1.5. This is 1.5. So I will just take my 1.5 here. Now we get to this other one. This is 1.35. This is 1.3. Already this is 1. Right? Now this is 1, 2, 3, 4. So if I'm having 1.3, I can say this is 1.1, 1.2, 1.3. This is my 1.3. And my 1.3 is as 1. So I will take trace it to this point and say this as it is. This is this again. These values are here. All these values are below. This is 1.3, which is the time. Now, my time, this is my 1. I count my 1, 2, 3. And now trace it to 3. This is my 1.3 now. Down. I will trace it to 1, 0.1. You get my point? So, this is at. It's not a straight line graph. It's a linear graph. Now, at my 4, so I come to my number 4. We have values of 0.5. I'll come here and just say, this is the 0.5. I'll place it to this line and mark here. So, I join this. Up with me. For me, I would say this value is too much. You could have something at least, let's say 2.
Even 2 years.
For me, I don't know if you accept me to.
You should do it again.
Eh?
Change.
Let's do it again now.
This is, you can think, we can't get on 5. So this one is up to 5 mil. This is up to 5 mil. We have water and we have acid. You can still do it. This thing is consumable.
Let's do it.
So it's going Changes. So, Dorcas, your attention is needed. Your attention is needed. Yes. So, I've shown you how to plot the graph. The graph is as simple as. Now, they say determine the rate constant. Remember this, what I was telling you. You will determine it. Pick your 5 mil. Yes. Right now, don't just this. Okay, what?
Kana. Oh, one over there, copy.
Ada buka. Da kono kama hiyo postpone test ila hiyo yangu tu leta mtu aleta abake bo mu akasa okay adi teke kabaro uko kwa hivyo 4-6 ebe kitu mo atilani okay amaga wo ko so ni ke di mo ko ilu benjika o ini ya nato wala ndio bye bye ebe ko okay kono sina bei ngora okay. Oh, Jesus. So sweet. Auntie. Auntie. Auntie in sound. Oh. Chai. I'm a son of the I don't know. She was surprised. I said, that's a surprise.
9 good man.
Yes. blue, my sister will tell me. I've been finding she tell me herself. I didn't want to say I'm serious. As I tell me today, I'm not too shocked. I said I didn't you know when you know the small place.
We don't
I don't even know English like this. Like my village really kill you because you buy Android phone. This is that kind of like messy place, like very dirty place. They kill you because you buy new clothes. I don't even talk of big things or car or small clothes. They kill you for small things.
Okay. So far, so good. We are done now. Okay. Concerning the rate constant, going to me this is the rate constant. Denoted as K. Okay. This is the formula. It will change in concentration over time. How do you know the change in concentration? Initially, this was the stock solution doctors prepared. Okay? Now, the initial end was what? 0.2. It will change. So the final and the initial was minus. Okay? Now, this is the new concentration. It still remains because there was nothing like water. So you still put it.
0.2.
Now the time is change in concentration is a different time. You do it, you have something like 0 divided by 0.26 equals to what?
0.
Thank you. Now, if you are going for the second one, you bring down this. You minus it by 0.15. Divide by the time.
0.49.
Equals to. What's the answer here? Now, what's the unit of rate constant? What's the unit of rate constant?
That second one. 0.10.
I don't know.
0.10.
What's the unit now? What's the unit of? Okay.
Oh my God.
In double unit then. Okay. That's the assignment.
Unit of what?
Rate constant. Motor. This is what you need to know now. Concentration. The concentration being what's the unit of concentration?
Gram per diem cube.
What do we prepare?
Moles.
Partially correct. This is capital M. This capital M can be mole per dm cube. Because it's a ratio, not a solid. Okay? So let's use capital M representing concentration. So if you have concentration and your term is what?
Second.
So So this the unit of M will be capital M
M second.
divided by seconds.
Yes, sir.
You want to get out of?
Mole per second.
Yes. Fashion. Come on. So you go for the third one. The third one, what was the concentration? You pick this first. 0.15 minus this 0.1 divided by